Hey y'all, today we're going to be talking about perpendiculars and distance. And so we talked about perpendicular lines a little bit the other day when we were writing equations. And so keep in mind that perpendicular still is going to mean the same thing. It's still 90 degrees and it's also still opposite reciprocal slopes. So keep that in mind as we go through this today. So this says the distance between a line. Okay, so look at this line here, line AB. The distance between that line and a point not on the line. Okay, so here's point P, so it's not on the line. The distance between those two things is going to be the length of the segment that is perpendicular to the line. So this blank is perpendicular. So the distance between a line, so between that yellow line and that purple point, is the length of the segment that is perpendicular. So this line in between them is already drawn, but if it wasn't, I would say, okay, how do you get the distance between that point and that line? You would have to figure out how to draw in a perpendicular line, okay, which is where opposite reciprocal slopes are going to come into play here a little bit later. Okay, so down at the bottom it says, this is a word that we're going to see a lot more later on. We're just kind of introducing it today, but this word of altitude. So altitude is a distance from a vertex, so vertex is like a corner, to the opposite base of the triangle. So an altitude is the distance from a vertex, so it's a line that we're going to draw in from a vertex to the opposite base. What it doesn't say here that you need to know is that an altitude is perpendicular. Okay, it has to be 90 degrees. So you can't just draw some random line. It has to be perpendicular. And so these three examples are showing how we have this line and we have this point that's not on the line. Okay, so from this vertex to the opposite base, I would need to draw in this perpendicular line, and that would be my altitude, okay, or my distance. My distance between that point and that line would be that perpendicular line. So when you look at the next one, okay, we're starting from that vertex, and if I go to the opposite base, so I go over here to this base, I would need to draw in a perpendicular line, and that would be the distance between that vertex and that line, okay? Also called your altitude. But when we talk distance today, that's what we're talking about. And then this last example is just a little bit different. So notice we're starting from this vertex here. And if I want to go to that opposite side, anywhere I draw from that point to that side within the triangle, none of these lines would be perpendicular. So that's not going to work for us. And so what you'll notice is that this line has been extended. And now because it's extended, I'll draw this line going straight down, and that would be my perpendicular altitude. So you won't have to do that often, but we will see one on the next slide where we have to do that. Okay, so these are just examples. You'll have some of these on your class kit today. Draw a segment that represents the distance. Okay, now when you see that, that means it's got to be perpendicular from point P to line AB. So I'm going to find point P, and I'm going to highlight over AB, and I'm just going to kind of extend it because sometimes that helps me see a little bit better. And so if we were to draw in a perpendicular line here, that perpendicular would look like this. Sometimes if it helps, you can grab a piece of paper and you can put that piece of paper up in between that yellow line and that red line, because the edge of a piece of paper is perpendicular. It's 90 degrees. So you could just put it up there and kind of make sure that that is actually perpendicular. Okay, on number 2, so again, we're starting with point P. and then I need to go to line AB. So again, I'm just going to kind of extend that to help me just see a little bit better. So if I wanted to draw on a perpendicular line here, I would just go straight down. That one's a little bit easier. So again, that's called my distance. It's also called an altitude. Okay, but when we talk distance today, that's what we're talking about. On number 3, I'm going to start with point P, and I need to go to line AB. Okay, and so again, I'm just going to extend line AB to help me see this a little bit better. And so if I were to draw this now inside of my triangle, I'm not going to be able to draw a perpendicular. So instead, what I'm going to do, since I've extended that line, it's a little bit easier to see now. If I draw this line straight down, that would be my altitude. So that would be my distance. And then number 4, again, starting with point P, and I need to go over to line AB. So again, I'm just going to extend that to help me see it a little bit better. And then this line is actually already drawn in for you because it's this line here because they're showing you that that's perpendicular. Okay? Again, that's called my distance, and that's also called your altitude. Okay? Those mean the same thing, distance and altitude. Okay, so now we're going to just practice some distance formula just to kind of get warmed up with actually finding an actual distance. So I'm going to go through this even though we've done this before. So it says find the distance between these 2 points. Okay, so I'm going to have distance equals, okay, so I'm going to subtract. So the formula is I need to subtract my x values. So I'm going to do -1 minus 8. That's my x's. And then I square it. Plus, I'm going to subtract my y values. So 3 minus 5, and I'm going to square it. And y'all, at any point, if I'm going too fast here, just pause your video, catch up, and then just press play again. Okay, so what I normally do here is I normally just go ahead and simplify this a little bit at a time. So -1 minus 8, that's -9. And if I square -9, that's 81. Okay, that number should always be positive because no matter what you square, it's going to be positive. Then I have 3 minus 5 is -2. And -2 squared would be 4. And so what we have now, if I simplify that, my distance would be the square root of 85. And I might have to look in my calculator and just see if there's any perfect squares that go into 85. I taught y'all a trick to do that. You should have learned it in Algebra 1, but not all teachers teach it. But if you go to your y equals and you type in whatever you're trying to get, so in this case 85, if you divide it by x, then you pull up your table, then you can look across and you can see if there's any perfect squares. You would see with this number that it'd be a lot of decimals, and we definitely don't want the decimals. And so I think the only thing that went into it was like 17 and 5, and neither one of those are perfect squares. And so this is your answer. We would definitely want to leave it that way. You do not want to put what that is as a decimal. That would not be okay. Okay, so here's our first real example. So this says line L contains points at -5, 3, and 4, -6. So this is line L that I'm highlighting in yellow. Find the distance between that line and point P. So find where point P is. We want to find the distance. Now keep in mind what we just said distance meant. Distance meant that perpendicular line. Okay, well, these lines look perpendicular to me, but we do not know for sure. Okay, also, normally you wouldn't even have a picture here. Okay, but we're just starting out with one with a picture. So I need to find the distance between that point. So I'm going to color here in green. We eventually are going to be getting this distance, okay, between that purple point and that yellow line. So this is just breaking it down in steps for us. So find the equation first of line L. Okay, so I want you to notice here where your y and x axis are, because it's kind of hard to see. Your y axis is here, and your x axis is here. Normally that y-axis is smack in the middle, and it's not, so it's just hard to see. So if I want the equation of line L, I'm just going to pick 2 points on there, and I'm going to get a slope. So this is rise over run. My slope would be -1. And my y-intercept here, it's going through -2. So the equation of line L would be y equals -x minus 2. Can y'all tell I'm doing this on an iPad? My handwriting's so much better than on the board. Okay, so that's the first step. The second step, write an equation that is perpendicular to line L that goes through point 2, 4. Okay, so we did this the other day. Okay, we did this that day. We did a lot of Algebra 1 writing equations. So we need an equation that's perpendicular to this one we just got. When you see that word perpendicular, you should automatically think opposite reciprocal. And so if the slope of that line was -1, then we need the opposite reciprocal of that, which would be +1. And so now I'm going to take this point and this slope and plug it into point slope. So I would have y minus 4 equals my slope, which is 1, times x minus 2. And then I'm just going to work this out. If I distribute that 1, nothing's going to change. So I'm just going to mark it out for now. And so now I can just add 4 to both sides. So we would have y equals x plus 2. Okay, now here we have a picture. So could I have looked at that other line and figured out that was the equation of the line? Yes. Okay, but you're not always going to have the picture. Okay, so we have to know how to do that. So there's our 2 lines. Number 3 says solve the system of equations to determine where they intersect. Okay, so again here, I have a picture, so I could see where these 2 lines intersect, but you're not always going to have that. And so I am going to just review how to solve a system. So our 2 equations that we had were y equals -x minus 2. And the other equation that we had was y equals, what was the other one? Y equals x plus 2. Okay, so here's your little systems review. The easiest way to solve a system is by elimination. To be able to do elimination, we need our x and y to be on the same side. So I am going to add this x in this first equation. So that equation now would be x plus y equals -2. And then in the second equation, I would need to subtract this x to move it over. And that would get me -x plus y equals 2. And now we have this set up to where if I add down right now, something is going to eliminate. So if I add down x and -x, that's 0. That's gone. That's why it's called elimination. Now I have 1y plus 1y, so that's 2y. And then -2 plus 2 is 0. So I'm just going to solve this. So divide by 2. And so y is 0. So that gets me the y value. Now we need the x value. And you can take that y value and you can plug it into any of those equations we have. We actually have 4 equations now. I'm going to choose the one I think looks the easiest, which is that x plus y equals -2. So I'm just going to plug 0 in. So I have x plus y, which is 0, equals -2. Okay, that 0 doesn't matter there, so x equals -2. So our solution, which is where they intersect, would be -2, 0. And so if I check where that was on the graph, where I circled in orange, that is at -2, 0. So yes, could we have seen that from the graph? We could have, but we're not always going to have that graph. All right, the number 4, use the distance formula to find the distance between 2, 4 and the point of intersection. Okay, let me show you what this is asking for now on the graph. It's asking for this area that I colored in green. Okay, It's wanting the distance between point P and the line, which is what we did on these slides. We drew in the distance, okay? We drew in that altitude, except now we actually have points, okay? So our sorry. Our point of intersection, we just found that, was at -2, 0. So now I'm going to get the distance between those 2 points. So distance equals, I'm going to subtract, goodness. I'm going to subtract my x values. So that'll be -2 minus 2 squared, plus I'm going to subtract my y values. So it'd be 0 minus 4 squared. So now I'm just going to simplify this. So -2 minus 2, that's -4. And if I square -4, that's 16. And then the second group, 0 minus 4 is -4. And if I square that, it's also 16. So if I simplify that, 16 and 16, that's 32. Okay, now I just have to simplify that radical. So I'm looking for the biggest perfect square in 32. That would be 16. So 16 times 2. I'm going to circle my perfect square and ask myself, what is the square root of 16? It's 4. So I'm going to bring out a 4, and then I'm left with square root of 2. If I were actually to type that in my calculator, it would tell me that the distance is like 5 point something, which makes sense. If we look back at this picture, if I wanted the distance of this green line, it looks like it would be about 5 units. Okay, so that number does make sense. All right, this is like the one that you'll see on your homework. You'll have a couple of these, and then after this, we're going to do some quadratics review, and then we'll be done. So graph the equation and plot the ordered pair. It says, using the steps from the previous example, calculate the distance from the point to the line. But what we're going to do is we're not going to go through all of the steps. Okay, I'm going to just show you what you would do if you saw this on your homework. So I'm going to go ahead and plot that point, -3, 3. And now I'm going to plot that line. So my y-intercept is 4. And my slope's -1. So I go down 1 over 1, down 1 over 1. And so my line would be this line here. So what you would want to do, because remember, if it's asking for the distance, we need a perpendicular line to draw in. Okay? And so I want to look at the slope of this line they gave me. My slope here was -1. And so what would be the opposite reciprocal of -1? It would be +1. So from that green point, I'm going to go up 1 over 1, up 1 over 1. So what I need is this distance that I'm coloring in green. So I want the distance between that point, which is at -3, 3, and the point of intersection, which I can see now, they intersect at -1, 5. Okay, and just to save some time here, because I know this video is going to get long, your distance here would end up being 2 square root of 2, because we get square root of 8. So if you want to, pause the video, see if you get to that answer. Or if you're good at distance formula, you can just keep watching as I move on to factoring. Okay, but that would be the distance that I would be looking for. So again, on your homework, when you see these two types of questions, plot the point, create that line, see where they intersect, and then you'll find the distance. Okay, we're going to do a quick review over factoring because we still do not all have it, and we are still going to see it pretty frequently. So at the top it says, what is the quadratic equation? That's y equals x squared. And the linear equation is y equals x. So if you see an x squared and an x, both in your equation, that tells me I have to factor. So here on number 1, I see an x squared and an x. That tells me I'm going to have to factor this. Okay, and I'm going to walk through number 1 a little bit slower, but then after that, I'm going to do all the odds with you, and then you'll do all the evens for homework. So in factoring, this is asking us to solve. That means we need to figure out actually what x equals. The first thing you have to make sure of is that this is all equal to 0. Okay, and this one is. So the next thing I'm going to do is I'm going to multiply my a times c. So I'm going to have 1 times 10, and that's going to tell me what I need to multiply to get. So I need to multiply to get 10 and add to get 7. So I'm going to start thinking of everything that does that. Okay, so that would be 2 and 5. Those multiply to be 10 and add to be 7. These are called your factors. Okay, so I'm going to write these down in factor form. So it'd be x plus 2 since it's a positive 2, and x plus 5 since it's a positive 5. Again, these are called your factors. This is asking us to solve, so it's wanting solutions. So this next part, you'll get to where you can do this next part in your head, but I'm going to write it out for this first one. So I would have x plus 2 equals 0, and x plus 5 equals 0. So on this first equation, I would subtract 2. So x would be negative 2. And in the second equation, I would subtract 5. So x would be negative 5. And these are called solutions. Okay? And so I think the way I wrote on your directions on your class kick to write your answers, you can just list them. And so I could just list this as negative 2, comma, negative 5. Or the other way around, negative 5, negative 2. It doesn't matter. And those are your solutions. So when we go down to the next one, I'm going to multiply a times c. So that multiplies to be 12, adds to be my b, which is negative 8. This tells me that this is going to be 2 negative numbers. So that would be negative 6 and negative 2. Okay, so I'm going to come over here, write my factors. The reason we can do this shortcut is because we have 1s in front of all of these x squareds. That's why we can do this. So I have x minus 6 and x minus 2. If I set these equal to 0, this is the step I'm going to save some time on for the rest of the notes. I would get x equals 6, and I would get x equals 2. And those would be my 2 solutions. Okay, so now number 5, I'm going to multiply a times c. So that would be 2 numbers that multiply to be 45 and add to be negative 14. Those 2 numbers would be negative 9 and negative 5. Again, these are going to be my factors. So I would have x minus 9 and x minus 5, all equal to 0. And if I set these both equal to 0, I would get x equals 9 and x equals 5. And those are your 2 solutions. We got factors and we have solutions. On number 7, notice here this is not equal to 0. That's a problem. We need to get it equal to 0 before we can do any factoring. So first I need to add the 12 over. So that gets me x squared plus 7x plus 12 equals 0. So I'm going to multiply a times c. So I need 2 numbers that multiply to be 12 and add to be 7. This would be multiply to be 12, add to be 7, 3 and 4. Okay, so my factors here would be x plus 3 and x plus 4. Remember, those again are called your factors, but we need to find solutions. So if I set those equal to 0, I would get negative 3 and negative 4. Okay, then the last one. So this says to solve. Notice these 2 angles. These are called vertical angles. And what we know about vertical angles is that they are equal. So I'm going to say x squared minus 31x equals 66. And we have the same problem we had on the last one. This one's not equal to 0. So I'm going to subtract 66 and move it over first. So that's x squared minus 31x minus 66 equals 0. Okay, and so now I multiply a times c. So what multiplies to be negative 66 and adds to be negative 31? That would be negative 33 and 2. So my factors here would be x minus 33 and x plus 2 equals 0. And so if I set those equal to 0, I would have x equals 33 and x equals negative 2. So hopefully with those examples, that's enough to kind of get you started on factoring. Of course, this is Algebra 1, so you should know how to do this, but I know we all don't. I just want to go across to number 10. I'm not going to work this one with you, but I just want to get you started on it. So on the one we just did, we knew those angles were equal. Here, we know these two angles are going to add up to be 180 degrees. And so you would do x squared minus 7x plus 150 is equal to 180. And before you can factor it, you have to get it equal to 0. Okay, so sorry that was a lot. This is actually my second time to make the video because the first time messed up. And this is 5 minutes less than it took me the first time. So that's good. So y'all complete your class kick. Let me know on there if you have any questions.